Alumina and coke are transported to silos at Hillside Smelter some 5.4 kilometers away by conveyor belt. The liquid pitch is transported to storage tanks at Hillside by road tanker. Aluminium is produced by electrolysis, and carbon anodes are an essential part of this process. Anodes are made in the following way. Coke enters the paste plant, where it is sorted, graded, and blended with spent anodes, which have been crushed for recycling. The coke mixture enters a preheating chamber via a bucket elevator, after which it is transferred to the bus mixer, where it is thoroughly mixed with liquid pitch to form a paste. The paste now enters a second mixer, the RH cooler, where the temperature is lowered as the mixing process continues. The paste is now ready for molding into anodes in the form of large blocks, approximately 1.5 meters by 0.6 meters by 0.6 meters. The process takes place in the Vibro compactor mold. The top section of the mold then descends, exerting enormous pressure onto the paste mix within the mold. At the same time, the mold is vibrated, which facilitates consolidation of the coke particles within the mixture. At the end of the process, the mold and the base separate, the anode is ejected and passed through a cooling tunnel where it is sprayed with water. The green anodes, as they are termed, are now ready for baking, a process which imparts strength and improves the electrical properties. Anodes are turned into a vertical position and placed 3 deep and 7 across in a gas-fired baking furnace. Baking takes approximately 20 days, gradually heating the anodes to a temperature of 1100 degrees Celsius, then cooling them slowly and evenly. Fumes from the bake furnace are treated at the Fume Treatment Center, FTC, to remove dust and other impurities, such as fluoride and tars, by absorption on alumina and by condensation. The baked anodes now enter the rodding shop, where anode stem attachment takes place. The anode stem is an electrical conductor consisting of an aluminium rod welded to an iron hexapod. Each hexapod, meaning 6-footed, is automatically aligned with 2 anodes and then lowered so that its feet enter the holes in the top of the anodes, which are then cemented in place with molten iron. Rodded anode assemblies are now conveyed to the reduction plant by means of a special vehicle known as the Anode Pallet Transport Vehicle, APTV. Reduction is an electrolysis process whereby fluorinated alumina is converted into molten aluminium in special containers called pots. The electrolyte, otherwise known as bath, contains the ingredients essential to the production of aluminium, alumina powder, aluminium trifluoride, and cryolite, the latter being used as a catalyst, which reduces the melting point of alumina. The other essential ingredient in the reduction process is electricity, which is fed directly into plant via overhead power lines. Transformers and rectifiers convert the 132 kilovolt alternating current incoming power into 1200 volt direct current, which is connected to the pot line. Each pot line consists of 288 pots connected in series. Each pot contains 20 anode assemblies and draws a massive 325,000 amps of electricity. The electrical charge passes from the anode through the electrolyte into a negatively charged cathode, situated at the base of the pot. Enormous heat is generated in the process due to the resistance of the electrolyte. Alumina is reduced to molten aluminium, which collects at the bottom of the pot. The aluminium is siphoned out of the pot into a ladle at the rate of 3.2 tons every 32 hours and is transported to the cast house. The addition of fluorinated alumina during the reduction process is controlled by a computer on each pot. The computer also adjusts the anode beam downwards as the anodes are slowly burnt away during the reduction process. The anodes are replaced every 27 days. The spent anodes, called butts, are taken to the butt crushing plant. Once crushed, the unused anode material is blended with coke in the paste plant for the manufacture of new anodes. Bath, cast iron, and anode stems are also recycled. The ladles containing molten aluminium are transported on ladle transport vehicles to a weighbridge where the ladles are weighed. The ladles are collected by ladle tilter transport vehicles and taken to the cast house. The door of the aluminium holding furnace opens. The ladle is tilted so that the liquid aluminium flows into the furnace. The empty ladles are then returned to the weighbridge, where they are collected by the LTVs and taken back to the pot lines. Aluminium in the holding furnace is kept molten by gas burners, which heat the inside of the furnace. Each furnace has a capacity of 60 tons. The vehicle here is called a furnace tending vehicle and has a skimming tool for removing oxidized aluminium, known as dross, from the surface of the metal. Samples of molten aluminium are obtained at this stage using a special spoon and poured into portable molds. These samples are barcoded with batch information and taken to the laboratory for analysis. When the holding furnace is full, hydraulic jacks tilt backwards and the aluminium runs into a launder, or trough, and flows to the casting wheel. Samples are again taken as the metal is cast. The casting device is a wheel, open on one side, with a groove running around its inside circumference, which leads into a series of nozzles placed around the outside of the wheel. As the casting wheel revolves, molten aluminium runs into the groove and flows into the nozzle at the bottom of the wheel, which feeds into an ingot mold, one of an endless loop of molds, synchronized to align themselves with the descending nozzles. The ingots are skimmed before they start to solidify and are transported in their molds to the ingot dropout zone, a point at which the molds are inverted, depositing the ingots onto another conveyor. Although solidified, the ingots are still extremely hot and now enter a cooling tunnel before they can be handled. After emerging from the cooling tunnel, every other ingot on the conveyor is inverted to ensure that the ingots interlock correctly when they are stacked into bundles. Stacking is carried out by a pre-programmed robot. Ingot stacks are strapped into 1-ton bundles by an automatic strapping device, and the bundles are loaded by the gantry robot onto a super pack trailer which carries 24 bundles on the short journey to the Strang Rennies Metal Terminal, SRMT, at the harbour. At the harbor, a straddle carrier removes the load of ingot bundles from the trailer and places the stacks in a holding area prior to shipment. Ingot stacks are transported to the quayside on a trailer for which they are loaded for shipment to overseas markets.